Good afternoon, my YouTube viewers. In this particular video, we're going to be talking about the chi-square test of independence, which is another measure of association. And the chi-square test of independence tests the associations between two categorical values. It outputs a p-value that indicates whether the association is statistically significant. So how we're going to prove this chi-square test of independence is we're going to write a program in Python to prove it. But before we write the program in Python to prove it, we're going to have to import two libraries that are going to be necessary in order to execute the program. So the first library that we're going to import is from scipy.stats. We're going to import chi2 contingency. So scipy is Python's scientific library. Stats is the statistical module within scipy. And the chi2 contingency is the model that we're going to be running a test on. And we're also going to import numpy as NP. So numpy creates numpy arrays, it creates distributions, and it also performs numerical computations. So after we've imported our libraries, then what we're going to have to do is we're going to have to create some data. And so we're going to data equals NP array, and it's going to be one list is 50, 30, 20. The second list is 30, 50, 20. And the third list is 20, 20, 60. And so we're going to perform a chi-square test on this array. So chi-square stat, that's like a test statistic, comma p-value, comma DOF, that's degree of frequency, comma expected frequencies equals chi-square contingency data. So your data is your observed frequencies, and we're going to be predicting on expected frequencies. So we're going to print the observed frequencies, then we're going to print the data, we're going to print the expected frequencies, and then the chi-square test statistic, and the degree of freedom, and the p-value. So we come over here. So we've got our observed frequencies, which is what I already stated. And then our expected frequencies are going to be 33.333 9 times. 3 list of 33.333s. And then your chi-square statistic is going to be 60. Your degree of freedom is 4. And your p-value is going to be 2.90 to the negative 12. So the p-value is going to be less than 0.05. So what that's telling you is there's a significant difference between the expected frequencies and the observed frequencies. So we come back here to the program, and we're going to interpret the results. If p-value is less than 0.05, you say there is a significant association between the variables. Else, you print there is no significant association between the variables, because your p-value is a proportion or a percentage. And the thing is that if your null hypothesis is there is no significant difference between the variables, between the expected values and the observed values. And the alternate hypothesis is there is a significant difference between the expected values and the observed values. So since the p-value is 2.90 to the negative 12, it's less than 0.05. So we have to go with the alternate hypothesis, which means there is a significant difference between the expected frequencies and the observed frequencies. And what it says in the program is there's a significant difference between the variables. So that means the null hypothesis is rejected and the alternate hypothesis is accepted. So that concludes this video. In the next video, we will be talking about some more methods of association, and I hope that you decide to watch it.